Hi children, already we have completed one video. Yesterday you have watched it, I know that, and in that particular video we have discussed about our real number. As a part of the real number, and we have discussed that natural numbers, whole numbers, integers and rational number. So, in the rational numbers, and we have discussed that one more topic, that we have expressed that every rational number in the form of p by q. That p by q, if you express in the decimal, and we can get that two types of the decimals there. This part in the last module we have discussed. The decimals are two types. One is terminating decimal, and the another one is non-terminating decimals, terminating and non-terminating. But I told you these non-terminating, again that the two types of the decimals are there, and first of all that is a non-terminating, repeating or recurring, and the another one is non-terminating, non-recurring. These are the all the types of the decimals. But I told you all the terminating decimals are the rational numbers, and non-terminating repeating decimals are the rational numbers. But non-terminating, non-recurring decimals are not the rational numbers. Those numbers are called as the irrational numbers. Actually, these are terminating decimal and non-terminating repeating decimals by dividing a number by the another one, that is called as a p by q. Yesterday we have discussed that 2 by 3. If you divide these 2 by the 3, and we get one non-terminating repeating decimal, so that is called as the rational number. But sometimes if you find or evaluate the value of this root 2, then the value will become that 1.414 so on, and in this case, and non-terminating, non-recurring decimals you will get. So those type of numbers are called as the irrational numbers. Understood now? So children, just remember that all the natural numbers, whole numbers, integers, and the numbers which can be expressed in the form of p by q, all these together it is called as the rational numbers. Actually, natural numbers, whole numbers, integers, these are the part of the rational numbers, because already we have discussed that those numbers can be expressed in the form of p by q. Let's see now, these rational numbers are expressed by using the letter q, and if you come to that another part, these non-terminating, non-recurring decimals are called as the irrational numbers. Irrational numbers are represented by the I, letter I, or else then we can write as the q dash. Children, you know that q, rational, q dash, which are not the rational. That means a number which cannot be expressed in the form of p by q is called the irrational number, that is a q dash. So these type of numbers, that means a number which cannot be expressed in the form of p by q, then you have the doubt, what are that numbers? That numbers can be expressed like this: root 2 and root 3 and root 5. If you evaluate all these values, definitely you will get non-terminating, non-repeating decimals only. But remember, root 4, I have skipped that term here. Why? Because root 4 is a perfect square form. That value is equal to that 2. Then it can be expressed as the 2 by 1. So it is called as the rational number. But root 2, root 3, root 5, these 2, 3, 5. Just to try to understand now, what is the common property of these 2, 3, 5? Those are the prime numbers. So any prime is under the root, definitely it is a irrational number. But I'm not sure, that means I can't say that all are the prime numbers. Root 6, if you take it also, then you will get irrational number only. Understood now? So all these type of numbers, if you evaluate all these, and you will get a non-terminating, non-repeating decimals, those numbers are called as the irrational numbers. So rational numbers are expressed by the q, and irrational numbers can be expressed in the form of q dash. Then you see here, we are discussing real number. Till now we did not discuss anything about that real number, but now I can say the set of numbers rational and irrationals, these two together called as the real number. So real number means, children, I think you understood now. What do you know about that real number? Real numbers is the union of the two sets. What are the two sets? One is rational number and the other one is irrational number. So rational and irrationals together, they are called as the real numbers. So in our 9th class we are going to discuss about this real number, that is q union q dash. That means rational, irrational together, they are called as the real numbers. So now if you come to that rational numbers, just children, just you see, now we have discussed these real numbers, that means rational number and irrational number. So let me explain these 3.5. I can ask you one question. 3.5, is this rational number or irrational number? Just you think and tell me the answer. 3.5, is this rational? Of course, you got the correct answer. 3.5 is definitely that rational number. How do we know that is a rational number? Because I told you rational numbers can be expressed in the form of terminating decimal or non-terminating repeating decimal. So 3.5, it is a terminating decimal. So clearly I can say that 3.5 is a rational number. Am I right, children? All of you also got the same answer, I know that. So 3.5 is a rational number. But you have one doubt. The rational number must be in the form of p by q. Then how can we convert these 3.5 in the form of p by q? That's you know very well, because in that our previous classes we have studied how can we change these terminating decimal into the p by q form. Just I will explain you here. Then 3.5. So tell me now, to remove this point here, just we can write divided by the 10. Actually, why? To remove that point we should take that divided by the 10. So the simple thing, here we are multiplying this number by 10 by 10. 10 by 10. It means then 3.5 into 10 is equal to 35 by 10. So 35 by 10, and if you reduce this fraction here, and can you say that what is the answer now? 5 table can divide these 35 and also that 10. So 5 7s are 5 2s are. So that it is a 7 by 2. So 7 by 2, clearly we can understand now. 7 is a p and 2 is represent that q. Then it is in the form of p by q. So the 3.5 can be written as 7 by 2 also. Then this is the conversion of a decimal form to that p by q form. And moreover, only the terminating decimals can we change into that p by q form? No, we can change non-terminating repeating decimals also. Before that, I like to say a few points about this non-terminating repeating decimal. 3.5, 7, 5, 7, 5, 7, so on. Children, tell me what type of decimal it is. I told you decimals are terminating and non-terminating repeating. So in that particular case, we can say 3.575757. Here all the decimals, that 57 is repeating that continuously, so that it is called as a non-terminating repeating decimal. So how can we convert this non-terminating repeating decimal into the p by q form? So let me explain some more points regarding this particular non-terminating repeating decimal. Actually, tell me now which numbers or which digits are repeating here. 575757. That means only the two digits are repeating the continuously. Then we can say the number of digits which are repeating in the non-terminating repeating decimals is called periodicity. Children, I will tell you that this can be expressed in by using the bar notation in this way. 3.57 bar over 57. So here the digits which are under the bar notation is called the periodicity. So now how many digits are under the bar notation? 1, 2. So there are 2 digits under the bar notation, so that it is called, the periodicity is a 2. And one more thing I can say, which number is under the bar notation, that is called as the period of the number. So which number is under the bar notation? So 57, that means 57. Then the period is 57. So once again I am repeating these 2 points which are the most important. One is the period, another one is the periodicity. So period, in the sense, the number which is under the bar notation is called the period. In the particular example, 57 is a period, and the number of digits which are under the bar notation is called periodicity. Then here in this example, periodicity is a 2. So I will give one more, 1.555, so on. How can we express this? Is by using the bar notation. That can be written here 1.5 under the bar. So how many digits are there under the bar notation? Only one digit. What is the digit? 5. So I can say there is only the one digit continuously repeating. So periodicity is a 1, and the period, the number which is under the bar notation is called the period, that is a 5. So period is a 5, periodicity is the 1. So I will tell you that one more, 1.235, 235, 235, so on. Children, just you try to understand now. In this number, you have to say that what is the period, what is the periodicity. Can you say? I think already you got the answer. Yes, you are right. And 1.235 bar over 235. So to find the periodicity, just you have to count the number of digits under the bar notation. So 1, 2, 3. 3 digits are there under the bar notation, so that the periodicity is a 3. And what is the period? Then period, the number which is under the bar notation, that is a 235. Then period is a 235, and periodicity is 3. So this we can say now. Why did we learn these points here? Actually, to convert the given non-terminating repeating decimals into the form of p by q, we need the help of this period and also the periodicity. Especially periodicity is the very important. Okay, now I will tell you how to convert non-terminating repeating decimal into the form of p by q. So 1.555, so on. This is a given problem here. It is a non-terminating repeating decimal, but I want to convert this into the form of p by q. The first of all, the given number you can consider as the x. So let x is equal to 1.5 bar. Just I am writing this is by using the bar notation, or else you can write directly 1.5555, so on. So now you have to understand that what is the periodicity, and consider this equation as the 1. And let's see what is the periodicity is here. Periodicity is a 1. What is the period? 5. Then periodicity is a 1. So you should